Equivalent fractions are super useful and they're really cool. So every single fraction has an infinite amount of fractions which are exactly the same as it, even though they look different. For example, if I've got 1/4 here, you can see if I slice it up further, I still have the same amount shaded, but fraction-wise, we'd usually call this 2 parts out of 8. So 1/4 and 2/8 are equivalent. They are the exact same fraction, even though they look different. Numerically, think to yourself, what happened to turn 1 into 2 and 4 into 8? You can see I've times the top and the bottom by the same thing. And as long as you multiply the numerator, top, and the denominator, bottom, by the exact same thing, then you can't go wrong. You're going to get an equivalent fraction, even if you times by something really weird. I could times them both by 13, and now it looks completely different to 1/4. But they are the same thing. I could times them both by 1,000. The numbers look different, but I have not changed the value of this fraction at all. One of the most useful equivalent fraction skills is being able to fill in a missing part if you know which denominator you want. So I want to change 3/5 into something over 20, but I don't want to change the fraction. I still want it to be 3/5. What did I times 5 by to turn it into 20? That was a times by 4. So as long as I do the exact same thing to the top, it'll all be good. 3 times 4 is 12, and now I've got a beautiful equivalent fraction. I want to change 1/25 into something over 100. What would I have to times 25 by to turn it into 100? How many 25s fit into 100? 4. I have to times that by 4. Whatever I do to the bottom, I'm going to have to do to the top. 1 times 4 gives me 1. Psych, it's 4. Don't make that mistake. So in summary, if you want to make an equivalent fraction, you must multiply the numerator and the denominator, the top and bottom, by the same number. It has to be the same number. Follow that golden rule and you're golden.